All right, ladies and gentlemen, welcome back to 5 Minutes of Math. And if you're still hanging in there with us, thank you so much. This is the homework assignment for the evening of Tuesday, January 9th, 2018. And it introduces the idea of direct variation. Okay, so if you've got a set of values and you're plotting ordered pairs, if you look at all your x's, like let's say you have -2, 1, -1, 0, 1, 2, and you multiply all of them by the same number, and you get a unique y value or proportional y value, then that's direct variation. So let's say you go and you do -2 times 3, and you get -6. Then you go -1 times 3, and that's -3. 0 times 3, 0. 1 times 3, 3. And then 2 times 3, 6. In every single case, we multiplied all of our x values by a single number and got a y value. And that's what we call direct variation. And it's easy. Let me show you what I mean. All right, so going on to our very first problem. So with number 12, if you guys look at this, we actually have a question that asks, is this relationship proportional? And we have pictures versus the profit for each one of those pictures. So we have 5 pictures, 6 pictures, 7, then 8 pictures. And our profit is 20, 24, 28, and 32. And in each case, we multiply by a certain number to get our y value. So what are we multiplying 5 by to get 20? 4. How do we get that? 20 divided by 5. So we multiply 5 times 4 to get 20. So let's see if that holds for the rest of our values. So let's look at 6. 24 divided by 6 is also 4. So 6 times 4 is 24. And it turns out 7 times 4 is 28. 8 times 4 is 32. So in this example, this relationship, yes, is proportional. So this is direct variation, and that's what this question is actually asking you all to figure out. So yes. All right. So moving on to the next problem. This is number 13, and it's asking the exact same question. Do we have direct variation? So is the relationship proportional? That's how we start when we look at this particular chart. So we have 200, 400, 600, 800. Those are our x values. And then we have our y values, 65, 115, 165, and 215. So what do we have to multiply each of our x's by to get the y? Well, with 200, we multiply by 0.325. With 400, though, we have to multiply by something different, 0.2875. 600, we multiply by yet again a different number, 600 times 0.275, and 800, we multiply by 0.26875. Since we're changing what we have to multiply by each time, no, this is not direct variation. All right, because if it was, we'd be multiplying by the same number. And where we have to change everything in the blue for each y value, not direct variation. All right, going on to number 14. All right, asking the same question. Is this relationship proportional? And here's our x and our y. Our x's are our ages, 10, 11, 12, and 13. And y is grade, 5, 6, 7, and 8. So in this case, we multiply 10 by 0.5 and we get 5. Then we go on to 11, we have to multiply by 0.54 to get 6. 12, we multiply by 0.583 to get 7. And 13, we multiply by 0.615 to get 8. And no, this is not direct variation because we change what we multiply each of our x values by to get our y's. So now we're going on to number 15. All right, same question. Is this relationship proportional? So what we're starting off with is we have prices and taxes. 10, 15, 20, 25. Then we have 70, 1.05, 1.4, and 1.75. And in this case, if you go and divide each of those y values by the x, 0.7 divided by 10 is 0.07. 1.05 divided by 15 is 0.07. 1.4 divided by 20, 0.07. You all should be seeing a pattern by now. We're multiplying by the same constant. Since we're multiplying by the same thing, yes, this is direct variation. All right, so thanks again for listening, and I will talk to you all again in 24 hours.